Big Dog Ole. Rise untethered climb. A climbing robot that grasps the micro-texture of the surface using special feet and special motions. The development team includes UPenn, Stanford, Berkeley, Carnegie Mellon and Boston Dynamics. The work was funded by DARPA. Little Dog. Little Dog was developed by Boston Dynamics with funding from DARPA. It is used for research on legged locomotion and learning by groups at MIT, Stanford, Carnegie Mellon, USC, UPenn and IHMC. RHEX Rough Terrain Robot. RHEX is a 30-pound robot designed for mobility on rough terrain. It is operated remotely via an RF link that includes a high-resolution video uplink. RHEX can operate right side up or upside down, as shown in the video, and goes for up to 4 hours on one charge of its batteries. RHEX has been around for several years, but we redesigned this version for ruggedness, long battery life, maintainability, and improved mobility. This version of RHEX was funded by the U.S. Army's Rapid Equipping Force. For more information about RHEX, visit www.bostondynamics.com. Sand flea jumping robot. Sand flea is an 11-pound robot with one trick up its sleeve. Normally it drives like an RC car, but when it needs to it can jump 30 feet into the air. An onboard stabilization system keeps it oriented during flight to improve the view from the video uplink and to control landings. Current development of Sand flea is funded by the U.S. Army's Rapid Equipping Force. Wildcat. Wildcat is a four-legged robot, being developed to run fast on all types of terrain. So far Wildcat has run at about 19 miles per hour on flat terrain using bounding and galloping gaits. The video shows Wildcat's best performance so far. Wildcat is being developed by Boston Dynamics with funding from DARPA's M3 program. Spot Classic. Spot Classic is a four-legged robot designed for indoor and outdoor operation. It is electrically powered and hydraulically actuated. Spot Classic has a sensor head that helps it navigate and negotiate rough terrain. Spot Classic weighs about 160 pounds. Atlas, the next generation. A new version of Atlas, designed to operate outdoors and inside buildings. It is specialized for mobile manipulation. It is electrically powered and hydraulically actuated. It uses sensors in its body and legs to balance and LiDAR and stereo sensors in its head to avoid obstacles, assess the terrain, help with navigation and manipulate objects. This version of Atlas is about 5 feet 9 inches tall, about a head shorter than the DRC Atlas, and weighs 180 pounds. Spot. Spot is a new smaller version of the Spot Classic robot, weighing 55 pounds dripping wet, 65 pounds if you include its arm. Spot is all electric, no hydraulics, and runs for about 90 minutes on a charge, depending on what it is doing. Spot is one of the quietest robots we have ever built. It has a variety of sensors, including depth cameras, a solid-state gyro (IMU), and proprioception sensors in the limbs. These sensors help with navigation and mobile manipulation. Spot performs some tasks autonomously, but often uses a human for high-level guidance. Handle. Handle is a research robot that stands 6.5 feet tall, travels at 9 miles per hour and jumps 4 feet vertically. It uses electric power to operate both electric and hydraulic actuators, with a range of about 15 miles on one battery charge. Handle uses many of the same dynamics, balance and mobile manipulation principles found in the quadruped and biped robots we build, but with only about 10 actuated joints. It is significantly less complex. Wheels are efficient on flat surfaces while legs can go almost anywhere. By combining wheels and legs, Handle can have the best of both worlds. Atlas 2017. Spot Mini 2017. Atlas 2018. Parkour Atlas 2018. Atlas does parkour. The control software uses the whole body including legs, arms and torso, to marshal the energy and strength for jumping over the log and leaping up the steps without breaking its pace. Step height 40 cm. Atlas uses computer vision to locate itself with respect to visible markers on the approach to hit the terrain accurately. Handle Robot reimagined for logistics. Handle is a mobile manipulation robot designed for logistics. Handle autonomously performs mixed SKU pallet building and depalletizing after initialization and localizing against the pallets. The onboard vision system on Handle tracks the marked pallets for navigation and finds individual boxes for grasping and placing. When Handle places a boxes onto a pallet, it uses force control to nestle each box up against its neighbors. The boxes used in the video weigh about 5 kilograms, 11 pounds, but the robot is designed to handle boxes up to 15 kilograms, 33 pounds. This version of Handle works with pallets that are 1.2 meters deep and 1.7 meters tall, 48 inches deep and 68 inches tall. Parkour Atlas 2019. Atlas uses its whole body, legs, arms, torso, to perform a sequence of dynamic maneuvers that form a gymnastic routine. We created the maneuvers using new techniques that streamline the development process. First, an optimization algorithm transforms high-level descriptions of each maneuver into dynamically feasible reference motions. Then Atlas tracks the motions using a model predictive controller that smoothly blends from one maneuver to the next. Using this approach, we developed the routine significantly faster than previous Atlas routines, with a performance success rate of about 80%.